Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to convert arithmetic and geometric sequences between explicit and recursive forms. How are we learning it? Through the explicit and recursive form part 2 notes and their explicit and recursive form part 2 assignment. When can we use this information? To re-examine issues in your life in different ways so that you can find the most appropriate method of solving the problem. How do you know you learned it? By getting a score of 4 on the explicit and recursive form part 2 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the explicit and recursive form part 2 notes, and then I'll give you time to complete the explicit and recursive form part 2 assignment on IXL. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the arithmetic and geometric sequences study guide and any incomplete assignments that you may have. Let's take a look now at the explicit and recursive form part 2 notes. The notes begin with the learning goals and success criteria. So let's talk about how we can write an explicit sequence as a pattern. Now, is that always easy to find? No, depending on the term, we don't want to have to keep calculating out. So the easiest way to do this is to write it in explicit form. So the explicit form for an arithmetic sequence is a to the n, meaning the value that we're trying to find, is equal to d, the common difference, times the number that we want, minus 1, plus the first term in the sequence. So an is the term we're trying to find. So for instance, a7 is the 7th term in the sequence. D is the common difference. N is the number of the term that we're trying to find. And a1 is the first term in the sequence. So let's look at an example. We have a pattern here, 2, 4, 6, 8, 10. The explicit form then is an is equal to d times n minus 1 plus a1. Well, we know d and we know a1. So we know d is 2. That was the common difference. And a1 is 2 because that's the first term in the sequence. Now let's take a look at this one. So we're given that an is equal to 3 times n minus 1 plus 4. And we want the 5th term. So 3 is our common difference. 4 is our first term. And we want the 5th term. So we're just going to plug 5 in for n. So this becomes a5 is equal to 3 times 5 minus 1 plus 4. Now we're just solve it. So 5 minus 1 is 4. So we're left with 3 times 4 plus 4. Well, 3 times 4 is 12 plus 4 is 16. So the 5th term in that sequence would be 16. So look at another example. Let's try to find the 10th term of this one. That's an is equal to negative 4 times n minus 1 minus 3. So again, we plug in 10 for n. So this becomes a10 is equal to negative 4 times 10 minus 1 minus 3. Well, 10 minus 1 is 9. So we have negative 4 times 9 minus 3. Well, negative 4 times 9 is negative 36 minus 3. Negative 36 minus 3 is negative 39. So the 5th term in that sequence is negative 39. Now, how can we predict the next term in a sequence? So let's say we know the 20th term. How do we know then what the 21st term would be? So the way this works is we're going to find the next term in the sequence if the previous term is 57, given that an is equal to an minus 1 plus 4. So what we're saying is the term we want is equal to the previous term plus 4. So we know the previous term is 57. So we're going to plug that in for this one that represents the previous term. So we have 57 plus 4 is equal to 61. So that's how we use the recursive formula to find the next term. Now let's talk about the explicit form for a geometric sequence. The explicit form looks like this. an is equal to a1 times r to the n minus 1 power. an in this case represents the term we are trying to find. For instance, A7 would be the 7th term in the sequence. R represents the common ratio. N represents the number of the term that we're trying to find. And A1 represents the first term in the sequence. So if we're given a pattern here, 3, 6, 12, 24, 48, we go ahead and fill this in. So AN we don't know. We do know A1 and we do know R. So AN is equal to, the first one is 3, and the R value we're multiplying by 2 each time, so R is 2. So this becomes 3 times 2 to the n minus 1. Now let's take a look at an example. We have AN is equal to 3 times 2 to the n minus 1, and we want the 5th term. So we're going to take that and we're going to plug 5 in for n. So this is A5 is equal to 3 times 2 to the 5 minus 1 power. Well, we know that 5 minus 1 is 4. So we have 3 times 2 to the 4th power. Well, 2 to the 4th power is 16. Then we multiply that by 3 and we get 48 is our answer. Now let's take a look at the recursive form for a geometric sequence. So that follows this pattern. AN is equal to R times A to the n minus 1. Now, what we're really saying here is the term we're trying to find is equal to the common ratio times the previous term. So if we look at this one, we have AN is equal to 4 times negative 1/2 to the n minus 1. And we want the 4th term. So we start here, and we're going to plug in 4 for n. And we get negative 1/2 to the 3rd power. Well, when we multiply that out, we recognize that negative 1/2 to the 3rd power is equal to negative 1/8. We multiply that by negative 4, and we get positive 1/2. So that would be the term that we're looking at. So let's look at an example here of working with recursive formulas. So we have AN is equal to 3 times A to the n minus 1. And we know that the previous term is 21. So we plug 21 in here. So we get AN is equal to 3 times 21. Well, we know that 3 times 21 is 63. So AN is equal to 63. Let's talk now about how to access your assignments on IXL using SBLink. So what you'll do is you'll click on the link that takes you to your SBLink, which should look like this. And you're going to log in the same way you would log into your computer. So the first part for your username is going to be the first part of your email address without the @sbcusd.ca.us. So it should be your last name, first initial, middle initial, and then the last 4 of your student ID. Then for your password, it's the same password you use to log into your Chromebook. From there, you'll go ahead and click Sign In. And it should take you to a page that looks kind of like this. You're going to go find the link that says IXL, which is right here. And I'm going to go ahead and click on that link. And it should take me to the IXL login page. So it should look like this. At the top right corner, it should say welcome and then your name. If it does not say your name, then you're not logged in and you won't receive credit for your work. As long as this is good, you can go ahead and close that tab out. And then you can go to your Google Classroom. And then you'll go and find the activity, which is here. And I'm going to click on the IXL link right here. And this will take me to the assignment that I need to complete. So that's how you log into your assignments on IXL using SBLink. Let's take a look now at the Explicit and Recursive Form Part 2 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that will take you to SBLink. This will allow you to log in and access your IXL activity. Once you've logged in, go ahead and come back to this page and click on this link. This will take you to your assignment for today. It says use the initial term and the recursive formula to find an explicit formula for an. Write your answer in the simplest form. Well, we can see that we have negative 49 is our a1, so an is equal to, and we know that we're going to have an minus 1 minus 4, so our common difference is negative 4. So I'm going to go ahead and put that in. So negative 4 times n minus 1 plus, in this case it's a1, so this would be minus 49. So minus 49. I go ahead and hit submit. It tells me I got it right and sends me on to the next one. So this one says an is equal to negative 12n plus 11. So it says the recursive formula should depend on an minus 1. So it says find a recursive formula. So in order to write this in a recursive formula, we know that we should be here an is equal to, and it's always going to start with an minus 1. So let's go ahead and do that. So we're going to click on this little button here so we can have the little part in the bottom. So this will be a, and then n minus 1. And then we're going to use the common difference. Well, we know that the common difference in this case is negative 12. So we put minus 12, and we hit submit. It tells us we got it right and sends us on to the next one. Notice, as we do this, my SMART score continues to go up. You're going to continue to work until you get a SMART score of 80. If you miss a question, that's okay. Your SMART score will go down a little bit. Just keep answering questions until you bring it back up. Once you're done with this assignment, you'll go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.